conference hall, a machine answered a question no human in the audience could match. It wrote working code in seconds, passed the bar exam. It scored at the top of the medical boards, and the room believed it was watching the birth of a mind. Then that same system was handed to a real company with real customers, real deadlines, real money on the line. And within weeks, it was quietly switched off. Not because it broke loudly, because it broke silently. It gave confident answers that were wrong, and no one could reliably tell which ones. Here is the part almost nobody puts in the keynote. Some of the most credentialed people in this entire field, researchers who built these systems, who understand the mathematics better than the marketers ever will, are saying out loud that today's AI is far less capable than you have been told, and that the failures are not bugs waiting to be patched in the next update. They are structural, built-in, load-bearing. This is the case for the skeptics, and it may be the most important argument in technology right now. Start with the flaw everyone has seen, but few truly understand. Ask a modern AI a question it cannot answer, and it will rarely stop. It will almost never say simply, "I don't know." Instead, it invents a citation that was never written, a court case that never happened, a statistic with the texture of truth and none of the substance. The industry calls this hallucination, a soft, almost whimsical word for a very hard problem. Because the machine is not lying to you. Lying requires knowing the truth and choosing to hide it. This system genuinely cannot tell the difference between what it knows and what it is fabricating, because in a deep sense, it does not know anything at all. It has no internal signal for confidence that is anchored to reality. To the model, a true fact and a plausible fiction look identical. Both are simply the next likely word in a sequence. And here is the part that should unsettle you. The more fluent these systems become, the more convincing their errors get. The mistakes don't grow rarer. They grow harder to catch. A few years ago, a group of researchers gave this problem a name that stuck. They called these systems stochastic parrots. The argument was blunt. A large language model is a machine for stitching together sequences of words based on statistical patterns in a mountain of training data, without any reference to meaning, and without a model of the world sitting behind those words. A parrot that has overheard 1 billion conversations can assemble sentences that sound profound. It does not understand a single one of them. The critics, among them the linguists and ethicists who first raised the alarm, were not claiming the technology was useless. They were warning that we had begun to confuse fluency with comprehension. That because the output reads like thought, we assume there must be thought behind it. But eloquence is not evidence of an inner life. The system holds no beliefs. It has no intentions. It carries no picture of the room it is so confidently describing to you. It is, at its core, an extraordinarily sophisticated act of imitation. And imitation, no matter how flawless, is not the same thing as understanding. But it passes the exams, you say. It scores at the very top of benchmarks that leave humans struggling. True. And that is exactly where the second crack opens up. Many of the tests used to prove how brilliant these systems are may have leaked, quietly, into the very data the systems were trained on. The model didn't reason its way to the answer. In effect, it had already seen the answer key. Researchers call this contamination, and it silently inflates nearly every impressive score you get shown on stage. Strip the familiar test away. Hand the system a genuinely novel problem out in the messy, unscripted real world, and the performance can simply collapse. This is the gap between the demo and the deployment. The polished stage version that dazzles a crowd, and the production version that stumbles the moment reality stops matching its training set. A benchmark is a controlled room with the furniture arranged just so. The world is not. And a machine optimized to shine inside that room can be strangely, helplessly lost the moment it steps outside of it. Then came the reasoning models. Systems specifically designed to think step by step, to show their work, to crack problems the older models never could. For a moment, it looked like the ceiling had finally been broken, until researchers pushed them harder. When one group tested these reasoning systems on puzzles of steadily increasing difficulty, they found something that should have been front-page news. Up to a point, the models coped. Then, as the problems grew genuinely hard, their accuracy did not decline gracefully, the way a struggling student might. Fell off a cliff, collapsing toward zero. Stranger still, as the puzzles got harder, the models sometimes appeared to think less, not more. As if, faced with real difficulty, they quietly gave up. The researchers called it the illusion of thinking. That long, orderly chain of reasoning that looks so much like careful deliberation may be, in the hardest cases, an elaborate performance of reasoning, one that shatters at precisely the moment real reasoning would be needed most. It looks like a mind at work. Push it hard enough and you start to see the seams. For years, one line of critics has argued that all of this was coming. That deep learning, the single technique underneath every one of these systems, has a ceiling built into it. That scaling up, feeding it ever more data and ever more computing power, produces diminishing returns, not a smooth straight line up to human intelligence. Their proposed fix is deeply unfashionable in a field addicted to bigger and bigger models. Combine the raw pattern matching of neural networks with older, unglamorous ideas, logic, symbols, structured rules, cause and effect. A hybrid, sometimes called neuro-symbolic, that would hand the machine the one thing the parrot has always lacked. Actual reasoning, actual understanding. Whether these critics are right is still fiercely debated inside the field. But their warning is worth hearing because it reframes the entire conversation. Maybe we are not one clever breakthrough away from machines that truly think. Maybe we have built something genuinely remarkable and fundamentally limited and mistaken that limit for a starting line. You can watch this argument play out not in a laboratory, but in a spreadsheet. Across the corporate world, companies have poured enormous sums into AI pilots, automations meant to cut costs, replace whole workflows, and deliver a clean return. And a striking number of them have quietly failed to deliver anything of the sort. The demo promised a tireless digital worker who never sleeps. The deployment delivered a system that needed constant human supervision, that broke on edge cases nobody anticipated, that produced errors expensive enough to erase the very savings it was meant to create. The automation turned out to be brittle exactly where the brochure had promised it would be robust. Now, this is not proof that the technology is worthless. Plenty of narrow, well-scoped uses genuinely work. It is proof of something more specific and far more useful to hold on to. The distance between a capability that impresses in a controlled demo and one that survives real contact with the world is enormous. And a great deal of the money now chasing this technology is quietly betting that gap does not exist. So how do you tell the substance from the spectacle? Start with a handful of questions the skeptics have taught us to ask. Was it tested on something it might have already seen, or on a genuinely new problem it had no way to memorize? Does it fail loudly, or does it fail silently with confident nonsense that only an expert could catch? Does it work in the demo, or in the deployment with real stakes and messy, unpredictable inputs? And can it tell you honestly when it simply doesn't know? None of this means the technology is fake, or that it won't reshape large parts of your life in the years ahead. It means the loudest promises deserve the hardest questions. The real skill in this era is not being dazzled, and it is not being dismissive. It is learning to see the line between what these machines can genuinely do and what we have simply been told they can do. So here is the question I want to leave you with. The next time a machine amazes you, will you ask whether it actually understood, or only whether it sounded like it did? Tell me where you land down in the comments.